Okay, here in worksheet number 12, we'll talk about basic counting rule and a tree diagram. So far, we studied probability of event where sample space was pretty much straightforward. For example, when we're talking about deck of cards, we know there are 52 cards in the deck. Let's say we want to pick a random letter for password. The cardinality of the sample space in that case is 26 because there are 26 letters in the alphabet. So pretty straightforward, we can count the sample space there. However, what if you want to pick two letters? The sample space is no longer just a letter of the alphabet, but it'll be like a string of two letters. So for example, it could be A, B, A, C, E, F, T, Q, R, K, P, K, whatever two letters could be. So obviously in real life, your password is going to be way longer than two letters, which is going to make the sample space more complicated. Since we're selecting multiple letters, it corresponds to the multi-stage experiment. In the worksheet, we'll study different strategies to count the cardinality of more complicated but more realistic sample space. All right, let's look at the first question here. Suppose that in the school cafeteria, you can choose a burger. There's a regular, chicken, or veggie, and fries, regular and curly. Suppose you're ordering for your friend, but you completely forgot what they wanted, so you're gonna just randomly guess. And we want to figure out the probability that you guess the order correctly. So it says write out the sample space, so all possible orders. So here we're picking a burger, we're picking a fries, so we can go regular burger with regular fries. That's one possibility. It could be regular burger with curly fries. It can be chicken burger with the regular fries, chicken with the curly, veggie with the regular fries, and veggie and curly. I think this is all possibilities. So your order has to be one of those 6 possibilities, right? So this is going to be our sample space. I'll write it like this. So what is the cardinality of the sample space? So how many choices are there? There are going to be 6. So when we combine the burger and fries, we're considering those two as one single sample. So if you look at all sample spaces, there'll be 6. What is the probability that your random guess order was the correct one? Well, the correct one they were supposed to order was one of the 6. You're picking one, so it'll be 1 out of 6. All right, let's look at a tree diagram. It's just a graphical representation of the sample space here, sample space of a multi-stage experiment. Again, we're taking multiple items, so we're not doing experiment once, but we're doing multiple experiments. So each experiment or selection is represented by a layer of branches. So this is how it's gonna go. So we're gonna start from here. So you can do it horizontally, you can do it vertically. Here I'm gonna do horizontally. So we're gonna start. So you're gonna pick your burger first, burger. So you have 3 selections for burger. So 1, 2, 3. So starting from here, we're gonna have 3 branches. 1, 2, 3. The reason it's called tree diagram is because each layer will have a bunch of branches. Depends on what the selections are. So the first one, we had a regular, we had chicken and a veggie. So this is regular, chicken, and a veggie, right? So this is my first layer of a branch. Okay, so second layer, we'll have 2 choices, additional choices for each branch, which is regular fries or curly fries. So for here, I can go this and this. So this is your fries layers, regular, curly, right? So you got 2 extra branch. From regular burger, you can have 2 choices for fries, right? Same, the middle one represents chicken burger. From there, you can have also 2 extra branches, regular fries and curly fries. We can write it like this. And then same here, you can pick veggie burger. Then you see also, maybe I need more space here. So from veggie burger, you can get regular fries and curly fries, right? So this is second layer is representing fries, right? So at the second level, we have 1, 2, 3, 4, 5, 6 branches. So this is my sample space represented by a tree diagram. So the very first branch represents regular fries and regular burger and regular fries. The second branch represents regular burger and curly fries here, and so on and so forth. CR, and then CC, VR, and then VC. So it's just basically sample space we wrote before, but now it's represented by a picture here. So this is my tree diagram. So let's see. It says how many branches are there on the first layer? Well, 3, because first layer we have 3 branches. And then how many branches are there on the second layer? We happen to have 6 there, right? So what does the third branch represent? So third branch, 1, 2, 3, that's coming from C and R. So that's chicken burger with regular fries. So chicken burger plus the regular fries, right? And the next question, do you notice a pattern for the number of branches at each layer? So, okay, first layer we had 3 branches, and then we went to 6. So how does it, why is it that we started from 3 and then went to 6? Well, 3 represents how many burgers. So this is burgers, right? So that one is not too bad. And then how does it become 3 become 6? Because for each burger, we had 2 choice of fries. So if you look at 2, 2, 2, that's basically 3 times 2. So that's how I got 6. So it's like, isn't it just 3 times 2? And 2 was your fries, right? 3 is the number of choices you have per burger, right? So when you count it, it's like 2, 2, 2. That would be 6, which is basically 3 times 2. All right, so that's the pattern I noticed. All right, number 3. It says, in addition to a burger and fries, let's say you get a choice of a drink. You can get a soda or you can get a beer. Draw a tree diagram to represent the sample space, including burger, fries, and a drink. So this is what I had before. Here I'm just going to copy and paste here. So now what's going to happen is from these 6 branches, for each of these 6 branches, now I'm going to have soda and beer. So soda, beer, soda, beer. Same here. Soda, beer. You can see what's going to happen. Soda, beer. It gets a little crowded. Soda, beer, soda, beer, and soda and beer. All right, so it says, what's the 5th branch? So that's my answer for the one with the soda or the drink. Look at the next question. What does 5th branch represent? So 1, 2, 3, 4, 5, 6. This one. So I want to see where this came from. So this person is getting soda, regular fries, and chicken burger. So chicken burger plus regular fries plus soda will be the 5th branch. How many branches are there on the 3rd layer? All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I noticed there's 12. And basically B and C are the same question. What is the cardinality of a sample space? That's just 12. Again, like, I'm not going to write everything out, but if I look at the first branch, there'll be regular fries, regular burger, regular fries, and soda. Second branch is regular burger, regular fries, and beer. So R, B. Still one more. The third branch is regular burger, but now it's curly fries, and then soda. So regular burger, curly fries with soda, and so on and so forth. So that's what each branch at the last layer represent. Do you notice a pattern? Okay, yes. Here we started from 3 on the first layer, then went to 6 on the second layer, and then went to 12 on the 3rd layer. Again, we talked about how we got 6, 3 times 2, 3 burgers times 2 fries. And then how about the last one? Well, from 6, we had 2 extra choices for drinks. So that's for drinks, right? So then you get 12 as an final answer. All right, I'm gonna have you pause, work on number 4, very similar question, and then we'll meet back at the basic counting rule when you're done. Okay, when you're done, now let's look at basic counting rule here. So if you're choosing one item from each of two separate categories, like burger and fries, where there are many items in the first category, was in our previous example, we had 3 burgers, so m was 3, and n many items in the second category, we had 2 types of fries, so n was 2. Then the total number of available choices is m times n. So that's the pattern that we noticed from our tree branch. If you have additional categories, then keep multiplying. Like when we added the choice of sodas, drinks, there were 2 types of drinks, so we just multiplied 2 again. The number of items, so we can multiply the number of items in each category. The total number of available choices will be the cardinality of our sample space, I think I'm going to just delete that part. In terms of tree diagram, each category is represented by a layer of branches. The total number of choices is represented by the total number of total branches at the last layer, right? So it gives you an idea of how the tree branch is gonna look like. So eventually we're not gonna have to draw every tree branch, because when you have like 100 branches, it's gonna be really difficult to draw. But at least we know the pattern, so we can calculate this cardinality of sample space easily like that. So let's look at the next question. I'm going to get started, and then I'm going to have you guys finish the rest of the worksheet. Let's say hipster coffee shop. You have 2 choices for your cold brew. You have Ecuadorian and Ethiopian. 3 choices for milk, and then 2 choices for sweetener. You are to select type of brew, a milk, and a sweetener. Okay? So it seems like I'm choosing brew first, then I'm going to choose a milk, and then I'm going to choose my sweetener. So it seems like there are 3 categories. So according to basic counting rule, what are the 3 categories? Cold brew, we have milk, and then we have sweetener. What is the number of items in each category? So brew, we had 2. Milk, we had 3. And then sweetener, we had 2. So that's like my m, that's my n, and then that's like the next number. How many coffee choices are available? Again, I'm not going to draw our tree branch, but I can use the concept and say, don't we just keep multiplying? Then we get my answer for that's going to be 12. Right? All right, so I'm going to have you finish the rest of number 5. I think you can work on number 6, 7, and 8, and I think that's the end of the worksheet.